Hi everybody, we're going to continue our lesson on simplifying radicals here. Okay, so let's begin. Let's state a new property here. And it just says the square root of a divided by b Actually, let's make this into an nth root. Okay, the nth root of a divided by b can be rewritten as, or evaluated as, the nth root of a over the nth root of b, like so. Okay, let's do two quick examples here. Okay, so for example, let's simplify. Well, let's do a square root. Let's do the square root of 8 over 9. Okay, well, this is fairly straightforward. And we're just going to use this property above to break it into two square roots like so. Okay, and then the square root of 9 is easy to evaluate. It's just 3. And then for the square root of 8, well, we just need to simplify it. Maybe I'll just do it up here. Remember, the square root of 8 is equal to the square root of 4 times 2. Just trying to find the factors of 8 that are perfect squares, in this case 4, and then we can break it into two square roots, like so, using the property from the previous video. And then I can evaluate the square root of 4 as 2 root 2 for our final answer. So therefore, this simplifies as 2 root 2 over 3. Okay, let's do an example with a cube root. Let's simplify. The cube root of 250 divided by 27. Okay, well, again, all we need to do here is just break it into two separate radicals. So this is equal to the cube root of 250 over the cube root of 27, and then from there, obviously the cube root of 27 is just 3, and then for the cube root of 250, I'm just going to do it off to the side here, maybe just down below here. What do we have? We've got the cube root of 250 is equal to the cube root. Remember, I'm just looking for the factors of 250 that are perfect cubes. In this case, we have 125 as a perfect cube. And then I can break it into two radicals. Okay, and then from there, the cube root of 125 is just 5 times the cube root of 2. Okay, so therefore our final answer is 5 times the cube root of 2 divided by 3. Good. Okay, so you can probably complete page 351. If I remember correctly, the very last question on the page, the one on the bottom in the bottom right corner, that one's going to require some factoring. You'll need to factor the denominator for that one. Otherwise, it should be fairly straightforward. Okay, let's start something new here. we're going to define what an imaginary number is. So here's the definition. Okay. The square root of minus 1 is equal to an imaginary number I, and I has this property that when you square it, it's equal to minus 1. Okay, now let's look at some background history here. Well, what is happening here? Well, you know, at a certain point in time, mathematicians realize, well, wait a minute, we can't take the square root of a negative number, because what's going to happen? Well, I'm looking for an answer such that when I square it, I get the inside back. But if you square any real number, you always get a positive result, right? So, you know, if I do, let's do some scratch work off to the side here. The square root of 4 is equal to 2, since 2 squared is 4. But, you know, if you try doing this with minus 4, well, maybe you think the square root of minus 4 is minus 2. But wait a minute, by the very definition, that would mean if I squared minus 2, I should get minus 4, which I don't. And so this was the issue we encountered. And so what we did was we said, okay, well, let's create this imaginary number, and we call this the imaginary unit. And it has the property that when you square it, you get negative 1. Okay? Alright, so this is our new task here, to work with imaginary numbers. So, for example, let's simplify. Well, let's do the square root of minus 4 and see what happens. Okay, well, you know, I could rewrite this as 2 perfect squares now, in fact. Okay, the textbook might take a different spin here, but I'm just going to write it like this. Okay, so this is equal to the square root of 4 times minus 1. Okay, and now I can break it into 2 radicals. This is equal to the square root of 4 times the square root of minus 1. Okay, and then from here, well, the square root of 4 is just 2. And the square root of minus 1 is I. So we're just left with 2i. And that's our answer. And so the moral of the story here is, if you ever see a negative on the inside, it means that you're going to have an I. But be careful, this is not true of cube roots. Cube roots, it's okay to take the cube root of a negative number. The result will be a real number. But with square roots and even roots in general, the result's going to be an imaginary number. But we're just going to focus on square roots. So for example, let's do this. Let's simplify the square root of minus 72. Okay, so what do we need to do here? Well, I think my suggestion would be that, okay, we've got a negative, so right away I know my result is going to be an imaginary number. So I'm just going to write an I to get rid of the negative, and then I'm just left with the square root of 72. And now at this point, we can just maybe simplify square root of 72 off to the side. And hopefully you can see that this is equal to the square root of 36 times 2. And then from here, the square root of 36 is 6. Remember, we can break that into 2 separate radicals, but I think we're probably a bit beyond that at this point. We can streamline our steps a bit here. So the square root of 72 is equal to 6 root 2. And all together, we get I times 6 root 2. Okay? Alright, You know, I think for me, I prefer to have the I on the right-hand side, but the book will often have the I on the left-hand side. I suppose it doesn't really matter, okay? The order of multiplication doesn't matter. I times 6 is the same as 6 times I, and so forth. Good. Okay, so this is all we're going to do for this video. For homework questions, you are probably well enough prepared to tackle the questions on page 356. Okay, so complete the questions on 351 first, and then do the questions on page 356. Okay, I'll see you soon.